Hi, everybody. Welcome back. We are still in quadratic functions, but we're moving on to a different section of it, okay? This time we are moving on to more of solving these quadratic equations, okay? So just like how you can solve a normal equation like in Algebra 1, right? You would have learned like 4x minus 1 equals 11, right? And like solving that for x. That would be solving a linear equation, okay? In Algebra 2, we learn how to solve these quadratic equations, okay? These equations with x squared in them, okay? And as you could imagine, because it's a more complicated equation, it's going to be a little bit more complicated to solve, right? And so when we were factoring equations before, right, when we were factoring these trinomials, we weren't really concerned with what the value of x was, okay? But when we factor them, okay, that actually really does help us to figure out what the values of x could be. Okay, um, and so that's what we're doing here in this video. We are factoring these equations and using the factoring to help us to solve and find what x could be if this statement right here was true. Okay, so we're just going to walk through a few examples of that. Okay, and this whole portion of the quadratic functions unit is about solving. Okay, and there's, again, with complicated equations, there's multiple strategies we can use to solve. And then in some situations, it is more beneficial to solve a certain way using a certain strategy based on how the quadratic equation is kind of with what terms are in the equation. Okay, so we're going to use factoring here, and let's jump into it. Okay, so this first one just says solve. Okay, and so when we have all three terms on the same side like this, okay, and just zero on the other side, that's when we can try to factor. Okay, if there were any terms over here on the right, we would have to move those over to get all the terms kind of together. Okay, so it's kind of the opposite of solving a linear equation where we want to isolate the x, whereas when we solve here, we want to move all the terms on the same side as the x's, right? So we can solve that way. Okay, and so now, just like before, I'm going to look at this trinomial and figure out, okay, how would I factor that? And I'm going to factor this one using tic-tac-toe, right? So let me set up my board real quick. All right, so I have my tic-tac-toe board based on these three terms, okay? And so again, I fill this in, okay? So what multiplies to give me x squared? Well, that's x times x, right? And then what multiplies to give me negative 28? Well, let's organize over here, right? So we got 28 times 1 is 28, 14 times 2 is 28, 7 times 4, okay? And again, usually it's a good idea to start with the ones that are closer together, okay? So 7 and 4, let's just throw those in there. But let's make one of them negative, okay? And here's a little bit of forward thinking for you, okay? In the past when I've shown these, I've just kind of made one randomly. But kind of thinking ahead, you might be thinking, oh, either the 7 is negative or the 4 is negative, okay? And if I'm trying to get those to add to be negative 3, right? How about the negative 7, right? Because if I multiply negative 7x, right? And then x times 4, 4x. If I add these, 4x plus negative 7x does give me the negative 3x, okay? So kind of as you get better with this strategy, you can use a little bit of forward thinking to determine where your negative is to save you some time, okay? So all that work showed me that this trinomial factors into x minus 7, right? These two groups and then these two, okay? So x minus 7, x plus 4. So this trinomial factors into this, and then I just write the equals 0 there because that part didn't change. So now, let me take a little break from solving this and explain something that's going to, a property or a rule that's going to allow us to solve this the way that we do, okay? And that's called the zero product property, okay? The zero product property says if you multiply two things together and they equal 0, that means that either A equals 0 or B equals 0. Or both, okay? They both could equal 0. But if you're multiplying two things together, any two things, if you're multiplying them together and the answer is 0, that means that one of the two things that you're multiplying has to be equivalent to 0. Otherwise, if you'd multiply them, it wouldn't equal 0, okay? And so notice what I have up here, applying the zero product property to this up here, okay? Even though they're groups, I have something multiplied by something else equaling 0, right? So I can apply the zero product property here and say, okay, one of these two groups would have to be equivalent to 0 for this to be true, okay? So using that rule, okay, I could think, okay, maybe this first group is the one that's equivalent to 0, x minus 7. If that group was equivalent to 0, okay, again, I have an unknown value in here. So I have to figure out, okay, what would x have to be in order for this group to equal 0? And that's easy, right? You just add 7 to both sides. So if x was equal to 7, that would make this group equivalent to 0, and thus making my answer equal to 0, right? Because 0 times whatever this group would be equals 0, right? Or the other possibility is that, okay, what if this group was equivalent to 0? X plus 4. What if that group equaled 0? Again, very simple to solve, right? I could minus 4 from both sides, and x would equal negative 4. Okay, so that would be another possible solution, would be, okay, if the x was negative 4 plus 4 is 0, and 0 times whatever this group would be would equal 0. Okay, so that's often true with quadratics. It's not always true, but oftentimes we're going to have two different answers. And we do here, right? So I have two solutions, x equals 7 and x equals negative 4. Okay, so that would be the solution to this. Two different answers based on factoring this, okay? And so that's the dealio. That's what we're doing. We're taking factoring a step further and applying it to actually solve them, okay? Let me do two more examples with you, and then hopefully we got it, okay? So we've got 2 and 3 up on the board here, okay? And you might notice these look a little bit different than the first one, okay? These are in like a little bit less of a position to be ready to be factored, okay? So that just means we need to do a little bit to get them in that position, okay? If you remember, I said that everything, all the terms need to be on that one side of the equal sign, okay? And right now, like if you look at number 2, the equal sign is there, and these two terms aren't over here. So the x squared's like, guys, come on over here. Let's get factored. So let's do that. So let's minus the 12x from both sides, okay? If I do that, I'm left with x squared minus 12x equals negative 35, okay? And again, my goal is to get it to be equal to 0, okay? So I just have to plus this 35 to both sides, okay? So x squared minus 12x plus 35 equals 0, okay? So sometimes it does take a little bit of work that you have to do first in order to get it to be ready to be factored, right? Because all these terms have to be together and not broken up by this equal sign to be ready to be factored, okay? So now it's ready, okay? And I'm not going to have enough room here, so let me erase and draw my tic-tac-toe board, because that's how we would factor this, and let's do it. Okay, so I've got my tic-tac-toe board here, all set up with this trinomial, okay? So again, I'm filling in x squared is x times x, and then 35, okay, 35. Not a whole lot of things multiply to get 35 other than 1 times 35 and 7 times 5, right? And so if I throw in 7 times 5, okay, right, and it's positive, so I should be okay, right? X times 7, 7x, x times 5, 5x, but then you check 5 plus 7 equals positive 12, not negative 12. So what's the deal? Again, it's a negative here, which means these two would have to add to be a negative, right? And again, don't forget, positive times a positive aren't the only things that can multiply to give you a positive answer, right? Couldn't you also do a negative times a negative equals a positive, right? So negative 5 and negative 7 still equals positive 35, but when you add them, it equals negative 12. Great. So now I have my two groups, and they would be x minus 5 times x minus 7 equals 0, okay? And now that I have those, I am going to erase my tic-tac-toe board just because, again, I'm out of space. Okay, so I've got x minus 5 times x minus 7 equals 0. Again, what I'm wondering is, okay, one of these groups has to be equivalent to 0 for this to be true, okay? So if x minus 5 equaled 0, you would add 5 to both sides, and x could equal positive 5. Or if the other group was equal to 0, you'd add 7 to both sides, and x could equal positive 7. Okay, so your two answers for this problem would be x equals 7 or x equals 5. Okay, two different answers for this. Okay. All right, number 3 here, 10x squared minus 100 minus 15x. Big numbers, right? First check we're going to do is, are all the terms by itself? Are all the terms, are all the terms on the same side of the equal sign, right? So that I can factor them. And no, they're not, right? This negative 15 is over on the other side, so I want to plus 15x to cancel that. And then I would be left with 10x squared, right? This 15x doesn't combine with any of these because even though this is an x squared, they're not like terms, right? They would need to have the same exponent, okay? And I'm going to throw this plus 15x right in the middle of these two terms because then it would be in the standard form of a quadratic, okay? So 10x squared plus 15x minus 100 equals 0, okay? And now you look at this and you might be saying, oh, big numbers, and they all end in 0 and 5. So, hey, those would have a GCF, and you would be right. Okay, these do have a GCF of 5. Okay, if you divide all the numbers by 5, you'd be left with, right in the GCF on the outside, you'd be left with 2x squared plus 3x minus 20 equals 0. Okay. Now you might be wondering, how does that GCF affect my factoring here? Okay, and it really won't. Okay, here's something cool that you could do if you just want to like get rid of that. Technically, right here, instead of factoring out the GCF, we could have just done that equation rule, right? That says if I do something to one side, I have to do it to the other side. If I divided both sides by 5 right here, right? I divide all these terms by 5, and I'd be left with this. Okay. Without the 5 here, just these 3 terms. And if I divide 0 divided by 5, what would I be left with? 0. Okay, so when you have a GCF, when you're solving an equation, you can really just divide it and kind of be done with it, okay? Unless there's a variable involved. If there's a variable in the GCF, then it's a little bit different. But if it's just a single number, you can just divide both sides by that and kind of just be done with it, okay? Not really have to worry about it at all. Okay, because that GCF is not going to affect what the value of x is, okay, what the answer is. So there we go. I kind of dealt with my 5 GCF there by canceling it out, and this is still 0. So great. So now I can solve and factor. Okay, again, let me erase, and I'm going to factor this equation. Okay, so I've got 2x squared plus 3x minus 20. Again, tic-tac-toe board coming. Okay, so I've got my groups there. Again, so I'm wondering, 2x squared is what times what? And so 2x squared would be 2x times x would be 2x squared, okay? And then negative 20, what multiplies to get negative 20 or just normal 20 as well? 20, 1 times 20, 2 times 10, and 4 times 5. There's the school bell. You gotta love the school bell. Even though there's no kids in the building. Anyway, so you got these 3 terms, and we are going to pick, okay, again, let's start with our lowest or our closest together terms. Okay, so let's just go 4 and 5. I'll flip them around, 5 and 4. Okay, and one of them has to be negative. Okay, so I would say negative 10x and positive 4. Okay, I just did that kind of randomly. So I add those up, 4x plus negative 10x would be negative 6x. No good. I want a positive 3x. So I actually think I had it right the first time. Let me take it back and do 4 and 5. Okay? And again, one of them has to be negative, so boom. Okay? So 2x times 4 would be positive 8x, and then x times negative 5 would be negative 5x. Hey, look at that. And when you add them, negative 5x plus 8x does give you that positive 3x, okay? And so your 2 groups are that and that. So I have 2x minus 5 and x plus 4 equaling 0, okay? And so again, these 2 groups are the factored form of this. And so now I look at those 2 groups and I think, okay, one of them has to be equivalent to 0. So I set them both equal to 0. So if 2x minus 5 equals 0, that's a little bit trickier to solve out. Okay, so you'd plus 5 to both sides. 2x equals 5. and then divide by 2. So you get a decimal or a fraction here, and that's okay. X equals 5 over 2, or 5 halves. Or the other one, easier to solve, x plus 4 equals 0, minus 4 from both sides. X equals negative 4. Okay, so those would be your two solutions to that one. So there's some solving by factoring problems, okay? Solving equations by factoring, so I hope that makes sense. We'll talk a lot more about solving these equations in different ways as well in other videos, but I hope that makes sense. Thanks for following.